Hi guys, am I audible and visible? बता देना बेटा. Inform me. Am I audible and visible? Let me check. Yes, Putti. Hello, Sueb. Honestly speaking, I'm not well, but Richa Singh. Hello. Who is this Richa Singh? Yeah, hi. Good evening. Good evening, Taha. Honestly speaking, not good, Sueb. But one more thing, honestly, that I was feeling bored after sleeping. Just I'm only sleeping. Hello, good evening, Aiva. Aiva. Let everyone join. Swab, inform in the group. Swab, form in the group, beta. Because I'll start from basic today. Okay. Already discussed with you all that we will start. We will be starting from basics. No, it's all okay, Swab. Okay, okay, Santosh. Okay, I can manage. I'm good. Swab, inform everyone. My voice is audible, na? Clearly audible, na? To you all. Basically, I was feeling bored after taking rest. Sahil. Okay, Swab. I'll Generally I keep 5 minutes. Wait. Let's wait for 5 minutes. I'm good, beta. What's up? Hello. Good evening, Rakshita. A new energy created when my daughter Rakshita comes. Rakshita joins my live session. Honestly saying, she is the daughter um, by whom I feel energized somewhat, some more energy. Daughters are daughters, right? Right, Rakshita? Hello, Sumit. Good evening. So where is your pair? Still he is missing. What happened? So can we start now? Oh, oh. Sayed, Swab is saying that he slept, but now he has deleted his message. So let's start. Let's start today's topic. Our today's topic is, as it's mentioned, it's topic of indices and logarithm. Basically, okay. Now see. First, I'll discuss one thing. Just we should continue with basics, na. We should continue with the theoretical concepts and basics, na. Tell me, or all are aware about the basics? I already taught you in offline classes, but still I think we must study from basic. It will take maximum half an hour. Maximum half an hour. More than that. Okay. Okay. See. So let's start with the initial point. First of all, the initial point is you must know about continued product. What is continued product? What is continued product? Okay. What is continued product? First of all, means I'm just moving from zero level to up level. Okay. So stay tuned so that you can understand everything basics in basic also. Okay. See, what is continued product? Product means when two items are multiplied. Basically, product means multiplication. So continued product means when two or more, two or numbers, basically numbers are multiplied, are multiplied. Then the resultant, then the resultant said to be continued product. Conti, okay. Then the resultant is said to be continued product. Okay. Now see. Suppose this is a number. Let's the a this is number a cross b cross c. Then these are continued product. Okay, conti. Hello Sarad, how are you? Okay, this is continued product. And one thing remember, each separate number a b are called as clear, are called as factors. Clear? Any doubt? Factors of the clear, clear. Okay. See, just you are seeing that A is different, B is different, and then is different. It's okay, sir. 50-50. 50-50. I was feeling bored. Oh, just I have scheduled the class. Okay, now see. A, B, C. these three are different numbers, different factors. Okay, what about if the factors are same? What about if the factors are, see, if factors are same, if factors are same, then what we say is, this is called, this will be power of a factor. Is it clear? Is it clear? Power of a factor. Okay. Okay. Factors are same, means suppose a is twice. Okay, let's see, a is twice, and it will be equal, this will be equal to a square. If a is thrice times, this will be equal to aq. And similarly, if a cross a cross a cross a, it's power, right? Clear? Okay. And see, what is this? AQ. It's AQ. A square. We pronunciate it as a square AQ. And this a to the power 4. Just see one thing. Fourth power of a. Fourth power of. Fourth power of. This is read as fourth power of a. But generally we read it a to the power 4. Fourth power. It's generally it's basically, according to mathematics, we should read it as fourth power of a, but we generally we can use a to the power 4. Clear? Clear? Now. Clear right now? Till now clear? Okay. Now see. What is the next point? Just we have discussed about a square, a cube, a4, and so on. What about if it's m times a cross a cross a cross up to m times? This will be equal to a to the power. Is it clear? Then this will be equal to a to the power. And now see what a to the power m. In this a to the power m, see this m and this a has meanings named. They are named as, this a is said to be base, and this is said to be index, power, or x. Visible? Visible? Okay. So we will read it as mth power of a. Mth power of a. Is it clear? Is it clear? Everyone? Is it clear? Okay. Now let's move towards law of indices. Law of indices. See, these are basic laws of indices. Okay, first law is a to the power m cross a to the power n plus, right? Second one, a to the power m upon a to the power n equal to a to the power n, right? Third one is a to the power minus m is equal to 1 upon a to the power m, right? And after pursuing cross multiplication, this will implies, or we can write first this one, a to the power m is equal to 1 upon a to the power minus m. Also, a to the power m cross a to the power minus m is equal to 1, right? Clear? Is it clear? Clear? Everyone? Don't worry, I'll not take more time today. I'll not take more time. Okay? Is it clear till now? Next. Oh, a to the power m to the power n is equal to a to the power mn. But here we have a note. We have a, what that note is? A to the power m to the power n is not equal to a to the power m to the power n. Okay? A to the power m to the power n is not equal to a to the power m to the power n. See, for example, we can take if it's 2 to the power 5, 2 to the power 2 to the power 3. Okay? Then this will be equal to 2 to the power 6, and that's equal to 64. But if we take 2 to the power 2 to the power 3, then this will equal to 2 to the power 8. That will equal to 256, which is not equal. So this one is clear. Clear? Now see, a to the power 0 fifth, a to the power 0 is equal to, remember this, okay, sixth, uh, a cross b to the power m is equal to a to the power m cross b to the power m, right? Seventh one is a upon b to the power m is equal to a to the power m upon b to the power m, right? Okay, and remember one thing, b should not be equal to 0 here in division case. Clear? B should not be equal to. Now let's discuss the one, let's discuss one of the most important formula. Formula number 8. See, suppose we have been given a to the power m upon, okay, see, first concept of, let's understand concept of root. What is root? See, if this is given a, one is a, and this one is, okay, now see, if nothing is written means there is 2, means this one will be equal to a to the power 1 upon 2. 3 is the given means a to the power 1 upon 3. Nth root is given means a to the power 1 upon. Clear? Nth root means it's given a to the power 1 upon n. Now see, just see this one. It's a to, can we write it as a to the power m to the power 1 upon n, right? A to the power m to the power 1 upon n. And what about 1 upon n? Means it's nth root of a, means this is nth root of a to the power m. Is it clear? Is it clear? Is it clear? Clear? Okay. Now see, a to the power, it's a to the power 0, every basic. But one important thing, to in order to solve questions, there are several other factors which will be important in uh, during your problem solving skills. See, 9 number. If a to the power m is equal to a to the power n, this will implies m is equal to, see, remember, when bases are equal, then exponent must be equal. When bases are equal, in case of equality, when bases are equal, then exponent, see, right? Clear? Okay, now see, just we have discussed all the part. See, I'll discuss some important questions, uh, only not basics question, more basics question, but I'll discuss some basic question, 1 to 2 question, and then some important question. And one important thing, see, last point, that if it's given that a to the power m is equal to b, this will implies a is equal to the power. Remember this. This is important. This is important. Remember. Okay. And there will several short tricks. Don't worry for tricks. There are several short tricks we'll discuss according to question. Okay. Suppose we have been given that 8 upon 125 to the power. What is this equal to? We know that it can be written as 1 upon 3 upon 125 to the power 1 upon. Am I right? Am I right? Can we write it like this? Okay. Now, can we write 8 as 2 to the power 3? 5 to the power 3? That's equal to the power swab. 3 3 cancel, 3 3 cancel. That's equal to upon. Is it clear? Is it clear? Is it clear now? Is it clear? Okay. Can we have a question with short tricks? One question, single question. One single question with. Can we? I'll discuss in both. I'll discuss in both method. Both method. I'll discuss both method. One general method and then short method. Okay. See, there is the question. 243 to the power n upon 5. Okay. Into 3 to the power 2n plus 1 upon 9 to the power n cross 3 to the power n minus 1 equal to. This is our question. Okay. See. Method 1. Method 1, how can we solve in general method? Means general method. Method 1, just it's 3 to the power 5 to the power n upon 5 into 3 to the power n plus 1 upon 3 square to the power n cross 3 to the power n. That's equal to 3 to the power 5 cross n upon 5 into 3 to the power 2n plus 1 upon 3 to the power 2n cross 3 to the power minus 1. 5 cancel and bases are equal, so we will add it. 3 to the power n plus 2n plus 1 upon 3 to the power 2n plus 2n plus n minus 1. That's equal to 3 to the power 3n plus 1 upon 3 to the power 3n minus 1. Means this one will be equal to 3 to the power 3n plus 1 minus 3n and minus minus plus 1. Then this will be equal to 3 to the power 2. That's equal to 9 is the correct answer. But can you assume that this is long? This is long. So don't attempt like this during your examination. Okay. See, method 2. It's a short method. In each type, such type of questions, in such type of question where n is not in denominator, remember n should not be in denominator in any situation. N should not be the denominator. Remember, this one is used only when n is not in denominator. Okay, remember this. Now see, Method 2. Put n is equal to 0. What will we get? 243 to the power 0 upon any number is equal to 0 into 3 to the power 2 into 0 is equal to 0 plus 1 upon 9 to the power 0 cross 3 to the power 0 minus 1, that's equal to this. 243 to the power 0 is equal to 1, 3 to the power 1 is equal to 3, 9 to the power 0 is equal to 1, 3 to the minus 1 is equal to 3 to the minus 1, and that's equal to 3 to the power 1 plus 1, that's equal to 3 to the power 2, and that's equal to 9. Okay, correct answer. Is that clear? Hello Nikhil. Is that clear? Both method clear? Tell me, both method clear? Fast. Okay, now just remember, I think we have discussed a question, recursive relation. Recursive relation. Hope you all remember recursive relation. Recursive relation. If x is equal to y to the power a, y is equal to z to the power b, z is equal to, and z is equal to x to the power c. Okay, then we have to find the value of ABC. ABC, just write it as x is equal to y to the power a, y is equal to z to the power b, z is equal to x to the power. Now, one thing remember, just take a clear, fix it down. What is the value of x? This implies z is equal to, what is x? Y to the power a to the power c, means y to the power ac. Is z is equal to, we have y to the power ac. Now what is y? Z to the power b. Z is equal to z to the power b to the power ac. That is z to the power abc. So we have z to the power 1 is equal to z to the power abc. This will implies abc is equal to 1. The formula is, since bases are equal, then exponent must be equal. Is it clear, everyone? Is it clear? Clear? Okay. Now see, one question I'll discuss from exponential equation. Okay, exponential equation. Question is, the question is, 5 to the power x plus 3 is equal to 25 to the power 3x minus x is equal to what? We have to find the value of x, right? See, is that clear, everyone? Everyone, swab, 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 swab. Very good. Very good, my gem. See, we have see a to the power m plus n is equal to, can we write it as a to the power m cross a to the power n as our first formula? As our first formula. Is it clear? Good evening, Hassan. Right? So, can we write it as 5 to the power x plus 3 is equal to 5 to the power x 5 to the power 3, right? Okay, now in this case 25 to the power 3x minus 4, can we write it as 5 square to the power 3x minus Now, can we write it as 5 to the power 6x minus 8? Right? Now, see, 5 to the power x plus 3 is equal to 5 to the power 6x. Yes, we have bifurcated the right hand side. Bases are equal. This will implies x plus 3 is equal to 6x minus 8. This implies x minus 5x is equal to minus 3 minus 8. This implies minus 4x equal to minus 11. Implies x is equal to 11 upon. Is it clear? Is it clear? It's 6x, sorry, it's 6x 5x 11 upon. Is it clear? No beta Rakshita, x is equal to 1. It's possible. No, not possible beta, not possible. X is, am I right? Am I right? Now see, next question. Next question. Don't worry, after completion, I'll share the PDF. Don't take tension. Okay. I think, hope you all remember this question, method of this question. If 2 to the power x is equal to 3 to the power y is equal to 6 to the power minus z, 1 upon x plus 1 upon y plus 1 upon z is the question of. Don't worry, tomorrow we will have a module session. Okay, tomorrow we will have a module session and we will complete the questions there also. Don't take tension. It was the basics, basic concepts, theoretical concepts on indices. Okay, just what I have told you, just take largest number. The largest number is 6 and bifurcate it. Bifurcate it means prime factorization. 2 cross 6. Put 1 on every part. Okay, write 1 is equal to 1 plus 1. What's in the power of 6? It's minus z. What's in the power of 2? It's x. What's in the power of 3? It's y. This will implies this is minus 1 upon x plus 1 upon y, and this minus from left hand side after coming to right hand side it will be plus 1 by z, and that will be equal to. Is it clear? Is it clear? Done? Done with the question? Now next question. Next question. 1 upon plus a to the power n minus m plus 1 upon plus a to the power n minus. What's here? So once again, okay, wait. See, I have told you, Sayed, I have discussed in the class that just take the highest, largest number. Consider largest number. Then 6 is the largest number. Okay, Sayed, 6 is the largest. Then prime factorize it. Prime factorize such that the factor must have the difference of 1. Then it's only possible in 2 cross 3. Am I right? Am I right, Sayed? Now, see, 6 to the power 1. It's 2 to the power 1 and 3 to the power 1. and then just write the power. First write the power and forget mathematics for sometimes, for a while at least. What's in the power of 6? It's minus z. It's minus z. What's on the power of 2? It's x. What's the power of 3? It's y. And simple one thing, if it's minus z in any side, then after changing this side, it's a transposition. It's basically it's a transposition. Then this will implies 1 upon x plus 1 upon y, and this minus 1 upon z means plus 1 upon z is equal to. Clear? This is the answer. Now Sayyid, clear? Sayyid, now clear beta? Any doubts? Still any doubts? Anyone? Okay, now next question should be like, see this one. Suppose one thing, simple, it's a very simple thing. It should be equal to, I think it should be equal to 1. Should be equal to 1, I think. Okay. See, what we have to do, one thing, see, you are watching about, this is negative, right? This is negative. Just don't take tension. Take m is equal to n. Nothing. Put m is equal to, don't take tension. Put m is equal to n. Yes, beta, clear. M is equal to, put m is equal to n. Just it will be 1 upon 1 plus a to the power 0 plus 1 upon 1 plus a to the power 0. That's equal to 1 upon a to the power 0 is equal to 1. 1 plus 1 plus 1 upon 2. That's equal to 1 plus 1. That's equal to 2 upon. That's equal to the correct answer. Is it clear? Is it clear? Is it clear? For today, it's enough. Extremely to understand the reason. Okay. You understand the reason. By tomorrow. By tomorrow. We'll have modules. Okay. For me, enough for today. Sorry. Personally, I'm not satisfied. But right now, I'm not in condition.